Like I said, I wanted to keep you updated on my progress with DeepRacer. And so I'm going to share some of the things that I've learned over the last few days. One of the interesting things is with calibration. It's very important to go through the calibration steps that are provided with your DeepRacer. So once you get it configured correctly and you have your web browser connected to the DeepRacer, you'll have the ability to select the calibration menu. And in there you can calibrate the throttle, and you can also calibrate the left-right turning of the car. So when you calibrate the throttle, it's very important to pay attention and make sure when you're working on the reverse throttle that the tires are actually going in reverse, and when you're working on the forward throttle, the tires are actually going in forward. So I talked to the team at AWS, and they shared with me that some of the cars had not been wired correctly, and it turns out that mine was one of those. And so when I went through the calibration, I didn't pay enough attention, and once I downloaded my model to the car and tried to run it, the car kept going backwards. So I went back, I paid more attention to what I was doing when I went through the calibration steps, and the car started going forward. Another reason to pay close attention to the calibration when you're trying to run your car on the track is the throttle or accelerator, as well as the left-right turning. So a couple of the experiments I did, I think I ended up narrowing the turning capabilities of the car too much. And while it made it go straight down the track, it was also clear that I had taken the car's ability to adjust to its environment a little too far out of the picture. So I didn't get as much of the obvious adjusting of the car to its environment and the car keeping itself straight down the track versus the car just kind of shooting down the track. Throttle I found to be very much a challenge also. The weight of the car and the energy it takes to get it started to begin with needs to be carefully balanced with the amount of throttle that the car has available to it once it gets rolling. If you give your throttle settings too high, you'll find that, again, your car just kind of shoots down the track and doesn't really have the ability to adjust to its environment because it's really moving too fast. So there's a very fine balance between the percentage of throttle that you give to the car for total speed versus balancing that with the amount of throttle it needs to have available to actually get started from a standstill. It's that piece of when the car's at a standstill, that initial inertia it takes to get it rolling and to move forward is where the balance of the throttle really comes to play. One of the other learnings from the last few days has been an opportunity to work closely with my AWS account team. When I shared with them my intent to use the DeepRacer as a way to excite our organization around machine learning and to have some fun working with the DeepRacer as a concept, they've been very supportive. So whenever I had a question, I talked about calibration earlier, they were very helpful with the calibration. They've also been very helpful with helping me use the SageMaker tool set. When we did the workshops at reInvent, we used a special set of tooling, the DeepRacer console. The DeepRacer console is in a preview that you need to go sign up for. But keep in mind, until the preview is released or that you're part of the early adopter program, I can't actually remember exactly what they're calling it, you can use the actual SageMaker tool set and the Jupyter notebooks. So they're very helpful in giving me the instructions on how to use the standard AWS tooling in SageMaker, Jupyter notebooks, RoboMaker, and the other components. And I have to say, I've been as impressed with the standard AWS suite of products as I was with the workshops. They have done an excellent job of putting together all the Python scripts that you need in order to set up your VPCs, to set up your S3 buckets, and to have the scripts to run and launch the RoboMaker so that you can actually see your simulations in progress. So a couple keynotes there. Leverage your AWS team. Work with them. They're as excited about this as we are, and they want to do everything they can to help you be successful. The other is the SageMaker stuff is great, and Amazon's done a great job making it very usable for everyone, and it's a good interim step until the console is launched. The third thing that I want to hit on in this quick video is talking about creating a test track. So it's very interesting to use RoboMaker and the other tools that AWS has put together in order to build and train your models, but the car's there for a reason, right? It's a physical representation of the neural network and the models and all the creativity that you can put into this. So you really want to see your car run, but you probably don't have the opportunity to or interest in making a full-size track. So what I did was we just made about a 6 or 7 foot straight section of track so that we could run the car on it and we could actually see if the car had learned. And we were able to do that, and you'll be able to see that in some of the videos that I'll be providing here, where you can actually see, you can hear the servos and you can see the car moving its way down the track. So the way I created the track is I just went down to Home Depot. I got a very inexpensive roll of tar paper or underlayment, roofing underlayment, which serves as the asphalt track. The underlayment I think worked well because it doesn't reflect light, it absorbed any light, which is more like the felt type tracks that AWS had at reInvent. And then also at Home Depot, they have multicolored different duct tape. So I got a yellow duct tape to be the center line. I got white duct tape to use to tape the asphalt track down to a green tarp. And then I also used the remainder of the asphalt to create a horseshoe border around my straight section of track. And what that did, again, is it absorbed the light and it gave the camera on the car a way to not see all the distractions behind it, right? Because we're training the models in these simulators, and the simulators have walls that, again, are absorbing light and don't have any characteristics or features to them to distract the camera. A great opportunity for me to train a model, download the model, and then prove that the car was actually following the model as it went down this 5 to 6 foot section of track. So it was great, it was very interesting, and it was nice to see again that physical representation of what I had been doing with SageMaker and the rest of the AWS machine learning products. Here are a few very short, few-second videos showing my DeepRacer running on my small section of track in my house, again, so that you can see that it's adapting to its environment and trying to adjust as it goes down the track. Well, thanks again for sharing this machine learning, reinforcement learning, and DeepRacer journey with me. I'm very excited to continue having these discussions with you as we continue to develop and understand not only DeepRacer, but machine learning and how it can bring value to our business